Hi, this is Mr. Wu, and welcome again to Disney Park Math. In episode 6, we'll work with scale factor featuring the ride Expedition Everest. Before we go there, let's talk about the Matterhorn, and this is the original Disney Park mountain thrill ride located in Disneyland in Anaheim, California. And here's an interesting series of posters or signs that was up there on the ride recently when they're doing a renovation. And interesting fact, so the Matterhorn bobsleds ride at Disneyland was the first Disney Park roller coaster and the first in the world to use a steel tube track design. Now, like Expedition Everest, it also features a snowman character and story. So it's some interesting information there. And there's the Matterhorn Mountain. Alright, now let's head to Expedition Everest, which is located in Disney's Animal Kingdom in Orlando, Florida, part of the Walt Disney World Resort. Now, Animal Kingdom is a unique park and it's in such a way that it's really a zoo embedded in a Disney park. So it's quite unique in that aspect. Now, the ride itself just has a really intricate and quite fantastic story. The fact that the actual ride was had to be created in a whole geographical region of the park and country in Asia, and they had to really recreate the Himalayas and a village and everything. So really quite an intricate story there, and really quite an intricate ride as well too. So basically you board a train and you head through the Himalaya mountains and you encounter the mythical Yeti creature. So let's go on a ride here and see what this looks like, and in the end there, see if you can even get a glimpse of the Yeti itself. Notice the vegetation and just how detailed this ride is. Think of the story here. Uh-oh, tracks out. Now the ride here does something really kind of cool, that it actually goes backwards. And we're back. Hope you enjoyed that. So if you've been on the Matterhorn, you can see this is quite an upgrade to that original steel ride there. And what a great piece of Imagineering, what a great story here. I hope you're able to actually see the Yeti there in the end. It's just so out there, you almost maybe don't even think you see it. I don't think I remember seeing it until I actually watched the video. Okay, now before we get to some problem solving and we talk about scale factor, I want to talk about the idea of forced perspective. And this is a really common technique in Imagineering. And the idea is this, that features of objects or scenes made disproportionately smaller look farther away, and this can create the illusion of increased distance or height. Now remember, we're working with the Himalayas and Mount Everest here, which is the tallest mountain in the world. So for example here is, pull out my pen. Okay, so here is Mount Everest, or the mountain range in the right here. Now the idea is this, the top here, if features of the top of the mountain are created disproportionately smaller, it makes it look farther away. In this case, it makes it look taller. So you don't notice this until maybe you come up closer to the ride and you see the scale of the actual train itself and see that, well, okay, actually there's something going on there. Also notice this elaborate and very beautiful picture here. This is in the country of Asia, and just the foreground, the trees and everything, that mountain really looks pretty far away. And then again, that's also an illusion, because really you could walk over there in a matter of minutes. It's not that far away. But it looks like a very impressive mountain range just based on the whole idea of perspective here and just some illusions kind of created with what we see with our eyes. Okay, now we're ready for some problem solving. So the Expedition Everest mountain is only about 200 feet in height. So see, it's really not that big. So forced perspective really plays a role there. The actual ride goes up to 112 feet high. Now the real Mount Everest in the Himalayas is about 29,000 feet in elevation. So what is the scale factor of Expedition Everest in? 1 to what? Hint, if you recall, scale factor is a type of ratio that compares two quantities with the same units. It doesn't matter what the units are, they just need to be the same. So we're going to create a ratio out of that. So go ahead and pause the video here, go ahead and solve that and see what you get on the next slide. Okay, did you work out a possible solution? Hope you did. Let's see what this might look like. So here again is our ratio. The maximum height of the mountain, 200 feet. The height of the actual Mount Everest, 29,000 feet. Notice we use the same units here, so feet over feet. Now, it really doesn't matter what units you use as long as they're the same. And what this does is it allows these units to cancel out. So as you might recall, scale factor really is a unitless ratio. It doesn't matter what units we use as long as they're the same. So let's simplify this. If we divide the top and bottom by 100, I can take out 2, 0, 0, take out 2, 0, 0, which leaves me with 2 over 290. And I simplify that again, divide the top and bottom by 2, I get 1 over 145. That works out really nice. So that is our simplified ratio, or our scale factor. So we say the scale factor is 1 over 145, or 1 to 145. So in conclusion, the scale factor of Expedition Everest is about 1 to 145. But remember, this is just based on overall height. Remember that forced perspective may also be at work, and that also creates the illusion of it being larger than it actually is.